So this continues the Pirate Data Science Unit 2 lessons. We're picking off with defining values. So we're used to seeing the equal sign in math class, but in Pirate it works very similarly. And things you should know is that if we were to enter in the code on the left over there on the interaction side of the screen, my dash name equals Maya. I'm going to type in Mr. Chan. Mr. Chan. Okay, and now we stored the string, or that bunch of words, Mr. Chan, into my name. Same works with numbers. Sum equals 2 plus 2. The sum equals 4. And then if we made an image and stored that into triangle, or made a triangle and stored that into image, 10 pixels big, solid, and we'll make it green because I like green. Now we can check image. You can see it's this tiny green triangle. Nice. So with our partner, we'll go through these. I'll demonstrate these up on the screen. Food is my favorite food, pineapples. Okay, you can check that. Great. Year, representing the current year, 2020, it's a number. Nice. Likes cats. Cats. I do like cats, that's why it's true. True means yes, false means no. Like cats. Oops, typed wrong. Like cats. Like cats. Likes cats. Likes cats. Equals true. Great. And now moving on to the next slide. Each row of the animals tables represents a single animal in our shelter. We can use row n methods to define values, typing the following lines in the definitions area. Okay, so we're going to type these onto the right hand side. You can see I did this in class already. On my program, that is lines 26 and lines 27. And what happens when you evaluate animal A? I should have ran this code already, so if you haven't done so, be sure you click run once. After pasting these lines of code in, animal A equals animals table dot row n 1. Okay, when we type in animal A, we see that that's mittens, and then animal B, type enter, that's Fritz. Define at least 2 animals. Okay, doesn't really matter what else you pick. Animal C equals animal table, animal dash table, dot row n, maybe we'll find the 26th one, then animal D equals animals dash table, row dash n, and maybe we'll pick the 17th one. Great. Since we edited our definitions area, you'll have to run your code again in order to check, okay, what's animal C? It's Daisy. And then my animal D is Nori. Okay, we'll practice with some exercises on page 9. We'll go over here, and this is the stuff we talked about last week in the exit ticket quiz, group quiz thing. You have your shapes table. Up here, a triangle, a square, a rectangle, and a circle. They have certain numbers of corners, and they are either round or not. So over here, I should have reviewed something similar to this in both classes, blocks 7 and 8. Shape A over here is the 0th thing. That's the first thing. That's shape A is this triangle, which has 3 corners and is not round. Shape B, look at shape table row N1, is the square with 4 corners, and it is not round. Shape C is the rectangle, and then shape D is the circle. We'll go through all these exercises. Shape D evaluates to the last row in the table, so that's this matching. Shape D matches this one, evaluates to the last row. Similarly, shape A evaluates to the first row. Shape B corners. So this is a column lookup. Shape B, that's the second thing. The square, looking up corners. This line of code evaluates to 4 up here. Shape C, looking up its is round column. Shape C here, is it round? False. So shape C is round, evaluates to false. Shape B's name, look at the second thing, we should evaluate to square. So shape B, square bracket name, matches square. Shape A's corners, so the triangle's corners should be 3, that's straight across, evaluates to 3. Shape D's name, okay, now this one's a little different because you have these two equal signs. As a reminder, that is a comparison. So let's first do this part, shape D's name. Shape D is the circle. So we see the circle on the left-hand side. Does the word circle equal circle? Yes, it does. That's why we see evaluates to true. I think that's it. Down here, we can type out some more stuff. I think in class we can look up, for example, this 0. 0, the only number on there relates to the last one, which is shape D. So you can type out shape, capital D, square bracket, and we want corners. So then we put in quotation marks, kind of like here. This line of code, in order to get 0, it would be shape D, corners, like that. And that's this worksheet. Now, here's the new stuff that we didn't quite get to block 7. We barely started. Well, we kind of got there, block 8. Defining functions. Suppose you work at the animal shelter, taking care of all the animals who live there. You want to make sure they're healthy, happy, and find good homes. For each animal, you might want to ask these specific questions. What kind of animal is it? Has it been fixed? When was it born, and is it a kitten? So we can do this by hand. We'll open page 2 in our booklets. Over here. Go to page 2. And we see this thing, okay? And then walk down the table one row at a time, and then check if each animal is fixed, okay? So we look here. It looks like Mittens is fixed. So is Sunflower, Sheba, Felix, Snowcone, Skip, Toggle, Boo Boo, Fritz, Maple, Bo, Skip, Nori, Lucky, Gila, Snuffles, so on and so forth, right? So that action, going down the table, looking at it row by row, we just did a lookup based on this column, the fixed column. And what's annoying about it is, imagine having like 1,000-something animals, right? Or you're studying quarterback data from the last like 15 years. You can go on forever. So that's why we have Pirate. We have this tool that helps repeat this. Computers are really good at repeating things over and over again, so that we as humans focus on the important parts. So that's why we look down here. Wouldn't it be great if Pirate had a function that called isFix for us to check every single row? And yes, it does. So we switch back here. In the Unit 2 starter file, on my line 38 now, fun is fixed r : r fixed, okay? That's the line. This is a custom function that was defined, so now we can check is-fixed animal A. Animal A is unbound, previously hot news. Oh, I capitalized it. So if I make this lowercase, yes, it's true. Is animal B fixed? That's true. And we can go up and check. Let's see, animal A, was Mittens actually fixed? Yes, fixed true. And then you can check animal B, press enter, and I scroll off to the side. I see that animal B, Fritz, was in fact fixed too. So you see that these values, these booleans, these true or false values match what was in there. Okay, so we can put these together. Now we know about row-n, we know about order by for specific tables, and then we can try filtering. Okay, this is really powerful. Notice the name of our function that we made is fixed. It's now placed into this table. We're going to filter by all the animals that are in fact fixed. So if I scroll on over, now our there should be just 18 things from our table. This represents all the animals that were fixed. Okay, notice it doesn't include any of the animals that were not fixed. We don't care about those right now. We just applied the isFixed function to every single row in the table, and we filtered them out and only got the things that are left over. It's a really big idea. So now when we go to our paper or term paper, do more research, we can care about the stuff. We can care about specific things that we want to analyze. And that's what this paragraph says. So now, that's great, but of course, we're not just interested in animals being fixed or not. We want to do more stuff, okay? We need to be able to make our own functions to do more complicated behaviors. This is what is called the design recipe. It walks you through how to make your custom functions. So block 8 we kind of got here. We added in a couple lines. Block 7, this is the new stuff for you. Maybe I will check my video length and probably pause it and then start a part 3.